So a little background on the messages we'll be using in the application. We want different messages to represent different actions. We also want messages that can be sent and messages that can be received. So for example, when the user joins a chat room, we want to send a join message. Also, when a user joins a chat room, they might want to get a list of all the current users in that chat room. So they might send a get users message and receive back a user list messages. Similarly with messages, we might want to send a get messages message and receive a message list message. So in the Java code, we'll end up with a message base class and then a set of derived classes, one for each type of message. On the client side, however, we won't be using derivation. Instead, each message will have its own message type, and this will simply be an ID. And we have an enumeration of those types here. So 1 will be a join message, 2 will be a simple message, so when we type something into the browser, that's the message that will be sent. 3 is a request to get all users, and 4 will be that list of users that comes back. 5 is a request to get all messages, and 6 will be the list of messages that we get back. You might think that join would be the first message we'd like to implement, as join is the first thing the user does when they bring up the site. However, the first thing the browser does when they first connect to the server is to send the get users message. So the browser wants to get a list of all the users that they can then display in their window. So the first message we need to implement is get users. So the first thing I'd like to do is to add the message base class that all our Java messages will derive from. So we can do this inside IntelliJ. So we do a new Java class, and this will be of type message. As we said, all messages will have a type field, which in the Java classes will be a private int type. And we'll add getters and setters for these. So we'll simply have a get type and a set type. Now that we have our base message, we can add the derived get users message class. So again, we do new Java class. This is called get users message. So this is the message that's sent by the browser to get a list of all the users. And this will return a users list message eventually. So get users message is quite simply a class that extends message. It's no more than that. So in our code, that message comes in, we identify the message, and we do some processing based on that message. Now that we have these messages, we can go back into our chat endpoint class, and we need to change our message processing. So on message, which we've reverted back to returning a void and just doing a broadcast, now rather than taking a string, we'll take something of type message. That means our broadcast needs to take something of type message. And in the broadcast now, rather than calling send text, we're going to call send object. And if we bring in the appropriate imports here, we'll also see that we need to add an extra catch clause. We need an encode exception. So in the case where we call send object here and we pass it a Java message, if there's no encoder in place for this message, then we'll get an exception and we need to process that exception. So we also need to define our encoders, and we do that where we specify the server endpoint. So that there are now a couple of changes to this. So on the server endpoint annotation, as we're adding more than one property to this, we need to say value equals for the URL, and then we need to specify here both the decoders. So decoders will be a message decoder class that we haven't yet written. So we do message decoder.class, and there'll also be an encoders, and the encoders will be a message encoder.class. And again, we haven't yet written that. So that's what we'll do next. So these classes are used when we want to decode an incoming message into the application and encode an outgoing message into the appropriate type. So we need to write the encoders and the decoders. Let's write the encoder first. So the encoder class we'll put into com.pluralsite.closes. It'll be a new Java class called message encoder. So that maps the type name we used on the server endpoint annotation. So we say message encoder, and this class implements an interface called encoder. It's a text encoder, and we want to implement a message. So encoder.text.message, bring in the appropriate type, so java.websocket.encoder, and then bring in the Pluralsight type, and then implement the methods. On here we have three methods. We have an init method and a destroy method. In this case, we'll do nothing with those methods. The important one is the encode method, and it's the job of the encode method to take the message object that's passed in here and encode that message object as JSON in this case, so the outgoing format. So we need to be able to encode a message into JSON format, and to do that we're going to use a JSON parser called Jackson. Jackson lives at jackson.codehouse.org. If you browse to that website, you can download the parser from there. As it says at the end, it's a fast parser, it does streaming, so it's a very nice JSON parser that we can use inside the application. To use the parser, we quite simply in our code here create something called an object mapper. And the object mapper lives in the com fastenXML Jackson databind namespace. Once we have the object mapper, so we create a new object mapper. We simply call mapper.write value as string, passing it the object. So we pass this the message object, and it stringifies that message object. In this case, turning that string into JSON. We want to return this value. And notice it's asking us to add some exceptions to this. There's a JSON processing exception that we need to handle. If that throws an exception, then we're going to, rather than returning null here, just return an empty string from the code. And that's it for the encoder. All the encoder needs to do is to take the message and turn that message into a string.